Hence, before watching this video, please make sure that you have watched 4 parts of a system of circles. At the outset, you might be wondering as to why this chapter's name is system of circles. Why this chapter is named after system of circles. A set of circles is said to be system of circles if it contains at least 2 circles. So if you notice, we've been dealing with the minimum 2 circles from the beginning of this chapter. In this session, we will be discussing the radical axis, radical center, and the properties of a radical axis, etc. The radical axis of 2 circles is defined to be the locus of a point which moves so that the powers with respect to 2 circles is equal, is said to be the radical axis. If x square plus y square plus 2gx plus 2fy plus c equals to 0 and s dash x square plus y square plus 2g dash x plus 2f dash y plus c dash equals to 0 are 2 concentric circles. For concentric circles, actually the radical axis does not exist. Circles, then the radical axis of 1 and 2. Radical axis is also a straight line. So, is a straight line represented by s minus s dash equals to 0. That is 2 into g minus d dash x plus 2 into f dash minus f y plus c minus c dash equals to 0. So, you proof, let p x1 comma y1 be the locus of the radical axis. So, the radical axis is defined as the locus of P which moves in a which moves so that the powers of P with respect to these circles are equal. So, I'll tell you the powers. The power of the point P is S11 Cp square minus R square. C is the center of one circle. P is a x1 y1 point. C is minus g minus f. R is the radius of the circle. Cp square minus R square, which we have discussed in the circles chapter. So Cp square minus R square, there we have discussed it clearly. So let Px1 y1 be the locus of the radical axis. So here the power of Px1 y1 with respect to s is equals to 0 is S11, that is, what is this? X1 square plus Y1 square plus 2G X1 plus 2F Y1 plus C. And what is the power of? The power of P x1 y1 with respect to s dash equals to 0 is, so s dash 1 so this is x square x1 square plus y1 square. Simply substitute x1 y1 in this. So 2g dash x1 plus 2f dash y1 plus c dash. So according to the definition of the radical axis, the power of P with respect to these circles are equal. So that is why I will equate these two, x1 square plus y1 square plus 2gx1 plus 2fy1 plus c is equals to x1 square plus y1 square plus 2g dash x1 plus 2f dash y1 plus c dash. So x1 square y1 square x1 square y1 square gets cancelled. So this is 2g, this is 2g x1 minus 2g dash x1 plus 2f y1 minus 2f dash y1 plus C minus C dash is equals to 0. So from this, 2 into G minus G dash x1 plus 2 F minus F dash into y1 plus C minus C dash equals to 0. Therefore, the locus of Px1 comma y1 is how much? 2G, 2 into G minus G dash into x plus 2 into F minus F dash into y plus C minus C dash equals to 0. So see that this is the behavior of one point in the plane is this. So therefore the locus of P is generalizing x1 y1 with x comma y to give rise to this. If you see this, this is ax plus b y plus c equals to 0, which is the equation of the line in the general form. So therefore, if you see here, if you see s minus s dash equals to 0 here, if you see s minus s dash equals to 0, then this gets cancelled, this gets cancelled. So we are getting 2x into g minus g dash plus 2y into f minus f dash plus c minus c dash equals to 0. Therefore, we can arrive to the conclusion that this is the radical axis of two circles is s minus s dash equals to 0. Let us see the theorem. The radical axis of any two circles is perpendicular to the line joining their centers. What is given is, there are two circles. There are two circles. So the radical axis of two circles. So this is the radical axis L equals to 0. How do we get? L is nothing but s minus s dash equals to 0. This is s equals to 0 and this is s dash equals to 0. Proof. Let the two circles be s x square plus y square plus 2gx plus 2fy plus c equals to 0, s dash x square plus y square plus 2g dash x plus 2f dash y plus c dash equals to 0. So the radical axis of s is equals to 0 comma s dash equals to 0 is, so s minus L, s minus s dash equals to 0. That means 2 into g minus g dash x plus 2 into f minus f dash y plus c minus c dash is equals to 0. The radical axis of any two circles. So let us take that c and c dash. The radical axis, this is perpendicular to the line joining their centers. So line joining of the centers is this. This radical axis is a perpendicular is what we need to prove. To prove this, the radical axis I get here. Let us find the slope of this radical axis. What is the slope of the line ax plus by plus c equals to 0? Minus a by b minus coefficient of x by coefficient of y. So, and c dash, what is the center of the first circle? Minus g minus f. What is the center of this? Minus g dash comma minus f dash. So then what is the slope of c dash? x1 y1 and x2 y2 is y2 minus y1 by x2 minus x1. Difference of y coordinates by difference of x coordinates. So let us so c dash, y2 minus y1 by x2 minus x1. So let us find the slope of this. The slope of the radical axis L equals to 0 is, let the slope of L equals to 0 be, I'll take it as m1. So m1 is equals to minus a by b. So minus of a is x coefficient 2 into g minus g dash by 2 into f minus f dash. 2 gets cancelled. So this is what we get. Let the slope of the line joining of the centers C1, C2 is B. M2 I will take. This is equals to y2 minus y1 by x2 minus x1. So this is x1 y1 and this is x2 y2. So minus f dash minus of minus plus f by x2 minus x1 minus g dash plus g. So this is equals to f minus f dash by g minus g dash. Now we can observe that the m1 into m2 is equals to minus 1. See, g minus g dash into f minus f dash. This and this gets cancelled, this and this gets cancelled. We are left with a minus 1. Since the product of the slopes is equals to minus 1, that is m1 m2 equals to minus 1. Therefore the radical axis L equals to 0 of two circles is perpendicular to the line joining of the centers of these circles. Note, for two touching circles, the radical axis is their common tangent at their point of contact. That is, if I have two circles like this, these are the two touching circles. S is equals to 0. This is S dash equals to 0. Let us suppose that these two are touching at the point P. This is C dash, or the centers of these two circles. Then this is the common tangent. This is the common tangent for these two circles. So here the common tangent is L equals to S minus S dash equals to 0. Here this common tangent is the radical axis of these two circles. Likewise, for two intersecting circles, the radical axis is their common chord at their point of intersection. That means I have two circles. I have two circles. These two circles are intersecting at a P comma Q. Then it is obvious that this is my common chord. What is this? This is the common chord. This is S equals to 0 and this is S dash equals to 0. So this is the radical axis. So this is L is equals to S minus S dash equals to 0. So this radical axis is this common chord is the radical axis here. The common tangent is the radical axis for the two touching circles. If the centers of any three circles are non-collinear, then the radical axis of each pair of the circles chosen from these three circles are concurrent. So in first year, this is L1 equals to 0 and this is L2 equals to 0. Then family of or passing to the point of intersection of these two lines is nothing but L1 plus lambda L2 equals to 0. Right? Then all those lines are said to be concurrent lines. In the similar way, here the thing is the three circles are like this. There are three circles. These three circles, their centers are non-collinear. That means centers are not lying on the line. That means, for example, this circle is there, another circle is there, this circle is there. So here C1, C2, C, C dash, C double dash are all lying on the same line. So these are the collinear points. So here the three centers are collinear. Right? Yes. Be the one circle is, this is S is equals to 0. That is x square plus y square plus 2gx plus 2fy plus c equals to 0. S dash, this is S dash equals to 0. X square plus y square plus 2g dash x plus 2f dash y plus c dash equals to 0. And S double dash, this S double dash equals to 0. This is x square plus y square plus 2g double dash x plus 2f double dash y plus c double dash equals to 0. The radical axis of S equals to 0 comma S dash equals to 0 is, let us suppose that let the radical axis of S equals to 0, S dash equals to 0 be L1 equals to 0. So L1 is equals to S minus S dash is equals to 0. Then this is 2 into G minus G dash X plus 2 into F minus F dash Y plus C minus C dash equals to 0. That means for these two circles, this is L1 equals to 0. Now, let the radical axis of S equals to 0 and S double dash equals to 0 be L2 equals to 0. That means L2 is equals to S minus S double dash equals to 0. That is equals to, so 2 G minus G double dash X plus 2 F minus F double dash Y plus C minus C double dash equals to 0. Likewise, let the radical axis of S equals to 0, S dash equals to 0 and S double dash equals to 0 be L3 equals to 0. That implies L3 is equals to S dash minus S double dash equals to 0. That is 2 into G dash minus G double dash X plus 2 F dash minus F double dash Y plus C dash minus C double dash equals to 0. Now let us take L1 plus L2 plus L3. All of them are getting cancelled. So is equals to 0 we are getting. So this can again be written as 1 L1 plus 1 L2 plus 1 L3. So L1 plus lambda L1 equals to 0 represents all the family of lines which are concurrent. Here these three lines are concurrent. That means, so the radical axis of these two is this and the radical axis of these two is this. See, all of them are meeting at one point. So if three or more lines are said to be concurrent lines, if and only if all of them has a point in common, all of them are passing through one point, then these lines are said to be concurrent lines. Therefore, the radical axis of these three circles are concurrent lines, and the point of concurrence is called what? Radical center. This is the radical center for the circle which is passing through these three circles, which we will be getting later on. The radical axis of any two circles bisects the line joining the points of contacts of common tangent to the circles. That is, for example, we have the two circles. Okay, so this is S equals to 0 and this is S dash equals to 0. This is the radical axis of both of them. So what is this? L equals to S minus S dash equals to 0. Now, let us suppose that this is a common tangent for both of the circles. This is T1 and this is T2. This common tangent touches this circle S is equals to 0 at T1, and this tangent touches the second circle S dash equals to 0 at T2. That's why, since the tangent is common to both the circles, it is said to be a common tangent, and this is the radical axis. So the radical axis and the common tangent are intersecting or meeting at point P. Then the radical axis bisects the line joining of the points of contacts T1, T2. It bisects. That means actually this is equals to this radical axis cuts this T1, T2 into equal halves. Bisects means cutting into two equal parts. That is, T1 is equals to T2. So this radical axis bisects the line joining of the 2 points of contacts. Let S dash equals to 0, S double dash equals to 0, S triple dash is equals to 0 be three circles whose centers are non-collinear. Clearly, the centers of these are non-collinear. All these points are not lying on the same line. So this is C dash, C double dash and C triple dash. These three are not lying on the same line. And no two circles of these are intersecting. See, these three circles are not intersecting circles. They are not intersecting. They are not cutting each other. Now listen, the radical center of these circles as the center of the circle. What is said to be radical center? So if two circles, these are the three circles, and the radical axis of these two circles is this. The radical axis of these two is this, and the radical axis of these two is this. So here, this is the point formed by these three radical axes. Therefore, this point is said to be the radical center. The point of concurrence of the radical axis is nothing but the radical center. Okay. So here, cutting these three circles, one big circle is formed. So one big circle is formed. This circle cuts these three circles orthogonally. We are familiar with the orthogonality. So if two circles cut each other at 90 degrees, it is said to be orthogonal. So then here for this circle, see, this is the center now. Okay, this is the center now. Then this is the circle. For this circle, again I am telling you, this big circle is formed by the three radical axes. This big circle whose center is formed by the point of concurrence of the radical axis of these three circles. So therefore this point, this radical center is the center of the big circle. This is C, for example. And so for obtaining any circle equation, along with center, radius is also required. So that radius is nothing but here the length of the tangent from the radical center to any of these circles as radius cuts the given circles orthogonally. That means, see this. So for example, there are three circles are there. So I have to have the radical, see, since this is the center of the circle, we need to have a radius, then h comma k is the center and radius r, then x minus h whole square plus y minus k whole square equals to r square, the circle will be formed. So there are three circles. Let us take one circle at random. So from this, actually this is the length of the tangent drawn from center to any of the three circles. Let us take this circle into consideration. So this is root S11. What is root S11? Length of the tangent drawn from the center to S double dash equals to 0. Here in the diagram, I have shown that the length of the tangent drawn from this center. What is this center again? This center is the point of concurrence of these three radical axes. This radical axis, this radical axis, and this radical axis. Therefore, this is the center of the big circle, which is cutting all the three circles orthogonally. And this is the center. And from this center, to obtain the radius, so draw a length of the tangent from this center of this required circle, which we will be getting through the point of intersection of these three radical axes. And from this C, so find the length of the tangent to any of these three circles. In the diagram, I have shown this to be the length of the tangent drawn from C to S triple dash equals to 0. How do we get? Simply substituting x1, y1 to this. Then we will be getting. So therefore, this is the radius now. So that means the same root S11 is the radius. Therefore, this is the center and this is the radius. We can find the equation of the circle cutting these three circles, having center as the radical axis and the radius as the length of the tangent drawn from the center to any of these three circles. Let us start the exercise 2b. Find the equation of the radical axis of the following circles. So these are the two circles given. This is the first bit from the first Roman first question. So let us take this to be S and this is S dash. Since this is not in a regular form, not in a general form, general equation of a circle is quotient of x square and quotient of y square should be 1, for which we need to divide once by 3. So this can be rewritten as x square plus y square minus 7 by 3x plus 8 by 3y minus 11 equals to 0. Now this is our s double dash, s dash. Now L is equals to s minus s dash equals to 0 or s dash minus s equals to 0. So this implies x square plus y square minus of x square plus y square gets cancelled. This is minus 3x minus of minus plus 7 by 3 x minus 4y minus 8 by 3y plus 5 minus of minus is plus 11 equals to 0. This implies 3 3s are minus 9x plus 7x, 3 4s are 12y minus 8y, 5 plus 11, 16 3s 48 is equals to 0. Minus 9x plus 7x is minus 2x. Minus 12y minus 8y is minus 20y plus 48 equals to 0. Take minus 2 as a common, then this is x plus 10y minus this is 16 threes. This is 24 equals to 0. This is by 3 equals to 0. Then s minus s dash equals to 0. X square plus y square minus of x square plus y square gets cancelled. Minus 3x plus 7 by 3x minus 4y minus 8 by 3y plus 5 minus of minus is 11 by 3 equals to 0. Now this is, take 3 as LCM, 3 3s are 9x plus 7x plus 3 4s are 12y minus 8y plus 3 5s are 15 plus 11 equals to 0 by 3. So 3 when it is transposed to 0, 0. So here minus 9x plus 7x is minus 2x. Minus 12y minus 8y is minus 20y. So this is 15 plus 11 is 16. 3 5s are 15 plus 11. So 15 plus 11 is 26 equals to 0. Therefore, if I take a minus 2 as a common, then x plus 10y minus 13 equals to 0. So let us take the second question now. X square plus y square, fourth bit of the same question. This is s and this is s dash. So L is equals to s minus s dash equals to 0. X square plus y square, x square plus y square gets cancelled. So this is equals to minus 2x plus 4x minus 4y plus 6y minus 1 minus 5 equals to 0. That means minus 2x plus 4x is 2x, 6y minus 4y is 2y, minus 1 minus 5 is minus 6 equals to 0. If you take a 2 as a common, then x plus y minus 3 equals to 0. Find the equation of the common chord of the following pair of circles. He is asking to find a common chord. That means these two circles, we can imagine that intersecting circles. For intersecting circles only, the common chord we have. So, for two intersecting circles, the radical axis is their common chord. So, otherwise, the common chord is the nothing but the radical axis. Solution. Let this be S and this be S dash. So, the common chord of two intersecting circles is the radical axis. That's why, so radical axis s minus s dash equals to 0 is x square plus y square minus of x square plus y square gets cancelled. Minus 4x minus of minus. So plus 5x minus 4x is x. Minus 4y minus of minus plus 6y minus 4y is 2y. 3 minus 4 is minus 1 equals to 0. This is the radical, this is the common chord for these two circles. And now the third bit is x minus a whole square. This is the, in the central form of the equation of the circle is given. This is the general equation, this is the central form with the center a comma b and radius c. Center b comma a and radius c. So this be s and this be s dash. This is equals to x square plus y square minus 2ax minus 2by minus 2x minus 2by plus a square plus b square minus c square equals to 0. This is s and s dash is x square plus y square. A minus b whole square is what I am doing and I am trying to set it in order. This is minus 2bx. This is minus 2ay plus b square plus a square minus c square equals to 0. The radical, the common chord is s minus s dash equals to 0. X square plus y square minus of x square plus y square gets cancelled. So minus 2ax plus minus of minus is plus 2bx minus 2by minus of minus is plus 2ay plus a square plus b square minus of c square minus of b square plus a square, these two gets cancelled equals to 0. This is equals to, take 2x in common. If take 2x in common, then this is b minus a. If we take 2y in common, 2y in common, then 2y in common, then this is a minus b equals to 0. This is equals to 2x into minus of a minus b we can write. 2y into a minus b equals to 0 we can write. So in both of them, 2 can be taken common. Then, and 2 into a minus b if you take common, then we are left with minus x plus y equals to 0 or x minus y equals to 0. Find the equation of the common tangent of the following circles at their point of contact. That means the radical axis is nothing but s minus s dash equals to 0. Let us take this to be s and this is s dash. The common tangent is nothing but the radical axis of two touching circles. So L is equals to s minus s dash equals to 0. X square plus y square minus of x square plus y square gets cancelled. 10x minus 2x is 8x. Minus 2y plus 8y, 6y. 22 minus 8 is 14 equals to 0. Therefore, this is 4x plus 3y plus 7 equals to 0. This is the common tangent at their point of contact. That means these two are the circles touching each other, and at this point of contact, this is the equation of the tangent. This equation of the tangent is we obtained by the concept of radical axis. S equals to 0, s dash equals to 0, and the radical axis is nothing but the common tangent of these two circles at the point of contact P. This is L equals to 0. In the similar way, the second question is same. Let us consider this to be S and this to be S dash. L is equals to x square plus y square. This and this gets cancelled. Minus of minus plus 2x. Minus 8y plus 4y. Minus 8y plus 4y is minus 4y equals to 0. Therefore, this is x minus 2y equals to 0. So, this is the problem that we have done in the circles chapter under the topic relative position of two circles, exercise 1E. The same question here. Show that the two circles touch each other. That means the two circles may touch each other like this, may touch each other externally, or may touch each other internally. So, if two circles touch each other externally, then C1, C2 is equals to R1 plus R2. If two circles touch each other internally, that is C1, C2 is equals to R1 minus R2, the absolute value of their difference. So, the condition for the two circles to touch each other is C1, C2 is equals to R1 plus R minus R2, we can say. Now, if the two circles touch each other like this, then the point of contact here in this context, the point of contact P is the internal center of similitude of the line joining of the center C and C dash. So, if the situation is something like this, for example, two circles touch each other internally, this point of contact P is nothing but external center of similitude. Here, R1x2 minus R2x1 by R1x2 plus R2x1 by R1 plus R2, R1 by 2 plus R2y1 by R1 plus R2, where x1, y1 is the center of the first circle, x2, y2 is the center of the second circle, radius is found through the formula root of g square plus f square minus c. Okay? Here, if this point of contact, if the situation is something like this, touch each other internally, then this point of contact is the external center of similitude R1x2 minus R2x1 by R1 minus R2, R1 by 2 minus R2 by 1 by R1 minus R2. So let us see that. Solution, let the given circles be S, x square plus y square minus 8x minus 2y plus 8 equals to 0. S dash is x square plus y square minus 2x plus 6y plus 6 equals to 0. But the difference with the solution of this to the earlier, the relative position of two circles is nothing but to obtain this common tangent, first the internal center of similitude in this case or external center of similitude in this case we found, and then at P, equation of the tangent at P x1 y1 to any one of the circles we found there, we got. So therefore, in the relative position of the circles, first of all at the outset we have found P, but here it is no need because for two circles the radical axis is nothing but their common tangent s minus s dash. Through this we will get the common tangent. So the common tangent of these two circles is equals to their radical axis at their point of contact. Therefore, L is equals to S minus S dash equals to 0. This is minus 8x plus 2x minus 6x minus 2y minus 6y minus 8 minus 6 plus 2 equals to 0. So, this is equals to, take 2 in common. So, that is minus 3x minus 4y plus 1 equals to 0. If you take minus in common, 3x plus 4y minus 1 equals to 0. Now, show that the two circles touch each other. So actually this is the point of so show that the circles touch each other and find the point of contact. So if it is not given what is the equation of the common tangent, but actually we have found, okay, it is not required first of all. Now, so to show that two circles touch each other, then C1 C2 equals to R1 plus or minus R2. Let us see what will happen. C1 is equals to C1 is the C1 is the first circle center, 4 comma 1. Radius is square root of 4 4 is 16, 1 1 is 1, minus 8. 16 plus 16 minus 8 is 8 plus 1 9. This is 3. C2 is equals to 1 comma minus 3. R2 is equals to 1 square 3 square 9 minus 6. 9 plus 1 10 minus 6 root 4 which is 2. Now C1 C2 line joining of the two centers, 4 minus 1 whole square 3 square 9, 1 plus 3 whole square 1 plus 3 whole square 4 square 16. So this is equals to root 25 5. Therefore C1 C2 is equals to R1 plus R2. C1 C2 is 5. R1 plus R2 is 3 plus 2 5. Therefore two circles touch each other. This case, this is not touch each other externally. Okay, and what more do we require to find? The point of contact. So the point of contact is the point of contact. So this is how the two circles touch each other. This point of contact P is nothing but an internal center of similitude. So therefore, the point of contact is equals to the point of contact is nothing but the internal center of similitude. This is equals to, so point of contact P is R1 x2 plus R2 x1 by R1 plus R2, R1 by 2 plus R2 y1 by R1 plus R2. That is equals to R1 x2. This is x1 y1 and this is x2 y2. R1 x2 3 into 1 3 plus R2 x1 2 into 4 8 by R1 plus R2 3 plus 2 5. R1 by 2 3 into minus 3 minus 9 plus R2 y1 2 into 1 2 by R1 plus R2 is 5. So this is 11 by 5 comma minus 7 by 5.